Unit conversion is extremely important. We oftentimes are using the English units in water and wastewater applications, but that's not always the case. Sometimes you also are in the metric units. So English units are things like PSI and gallons and inches and feet, those types of things. And then the metric system would include things like kilowatts, um, kilograms, grams, milliliters, those types of things. So a lot of times you're going back and forth, especially when you have dosage calculations and sometimes depending on the type of fluid that's involved. So I'm going to give you an example. So I pulled from the RDP packet a couple useful little tools here. These are all unit conversion factors, and then there's the weight volume relations there between they always use water, the weight of water per gallon of water, and then they have a general conversion from gallons to cubic feet. This is English unit still here, but you could also, of course, go from grams into pounds to kilogram conversion. That's very useful. Grams to pound, and then they have ones within the metric system, grams to kilograms, grams, so it works out very well. So this actually should be milligrams from there, but 1,000 milligrams per gram. So sometimes even in the documentation you have to make use of some science sense. It's 1,000 milligrams per gram. So when you look through these, it's very useful as you're solving a problem to identify the units that are being asked for in the problem. So sometimes they'll say, what's the dosage in milligrams per liter? Or they might give you these values. You should write them out and see what the final units are going to be, because you can easily figure out what formula to use, sometimes creating it yourself along the way, if you just know, well, hey, I need milligrams on top and I need liters on bottom. Well, how do I get there? So let me give you an example. Let's say that we have 100 cubic feet per minute. So I say I have a flow of 100 cubic feet per minute. So I'll call that feet cubed. And I'm going to make what I call a little divisor line here for 1 minute. So we are actually setting up a unit conversion chart. Really, this is just a bunch of fractions all multiplied together. So you always start off with what you're given on the left. If you don't have something on the bottom, so something per minute, something per second, something per gallon, then you can just put a 1 there as a placeholder. So we have 100 cubic feet per minute. And we want to turn this into, let's say, gallons per hour. Or let's make it really interesting. Let's make this gallons per day. So we're looking at GPD, gallons per day, as our final result. So if we want to visualize that, then it would look something like this. Gallons over day. And so that shows us that we have to reach this end result somehow. So we say equals, we don't quite know how many gallons per day. All right, no problem. So we can choose one of these to convert. We want to get into gallons as our unit of volume. So we have cubic feet. Now let's see what we can do. We see that 1 cubic foot is equal to 7.48 gallons. So to make it easier on you, I'll change it from feet cubed and I'll call it cubic feet. It's the same exact thing. And just like any factoring, we can actually cross out things that are in the numerators versus the denominators. So we want to put this conversion factor here. So 1 cubic foot is half of our conversion factor, and the other side goes on top, 7.48 gallons. And then the cool thing is that these units cross out. We're left with just the numbers here, and they're going to multiply through and divide through if needed. So we're actually halfway there already. We've gotten the gallons, so that's good. And sometimes I like to go over and just say, check, got that. Now we got to handle the per day part. So in this case, we have a conversion from minutes into hours, and then we can go from hours into days pretty easily, right? You just divide by 24. But if you want to do it formally, we say, okay, now I'm trying to tackle this minutes. So I know 1 minute, or rather 60 minutes. There we go. 60 minutes goes on top because the minutes have to be canceling each other. One's in the numerator, one's in the denominator. That will work. The other half of that is 1 hour. So 60 minutes per 1 hour. And I know that the minutes cancel each other out. So I'm not quite there. Now I have what would become gallons per hour, and that's okay in some cases. But I want to get gallons per day. So I know that there are 24 hours in every 1 day. So the 24 hours I know goes on top because I need it in the numerator for these to cancel. And that's per day. So all I've done is I've set up a little skeleton structure here, which are really, again, just a bunch of fractions multiplied together. And I've used the conversion factors to isolate gallons per day. So now my units are correct. Well, what do you do next? Well, you multiply through. You say 100 times 7.48 times 60 times 24, and that's all going to be divided over 1 times 1 times 1 times 1. It's not always so simple. Sometimes you do have non-1 numbers in the denominator. But ultimately, that's going to yield 100 times 7.48, which I already know what that is, times 60, multiply again by 24. It's going to be over 1 million gallons per day. And I could round that as appropriate. So this is one example of unit conversion, and I want to remind you again, this all comes from the data reference packet. So all these conversions are here. You just have to orient yourself to these. And again, every once in a while you might see an error. Those get corrected over time. This would be milligrams is a gram, and this is 1,000 grams is a kilogram. So just make sure that your science sense is tingling every now and then too, and double check things. Don't be afraid to ask a question too if someone hands this to you and you see that something looks like it's a little awry. So another useful scenario here is the Fahrenheit and Celsius or centigrade conversions. So they're really very plug and chug. You can go from Celsius to Fahrenheit by using this formula. You can go from Fahrenheit to Celsius by using this formula. I'll show you one of those worked out. So let's say that we have 20 degrees centigrade or 20 degrees Celsius. So all I would need to do is I say 20, see where I'm plugging this in, multiplied by 9/5 plus that 32-degree freezing point. So when I plug those through, (20) times 9 divided by 5, add 32. I find that 20 degrees Celsius is 68 degrees Fahrenheit. Okay, well that's okay. I understand that. Let me check my work. Let me do this with instead 100 degrees Celsius. So that would be the boiling point. And I know that in Fahrenheit, that should be, what, 212, I believe? Well, let's see. 100 times 9 divided by 5 plus 32. 212 degrees Fahrenheit, so that's great. And the same thing's true going from Celsius, or Fahrenheit to Celsius rather. You just plug back in this equation, and I might as well show you one since we're here. Let's go back from 212, the boiling point in Fahrenheit, subtract that 32 degrees, multiply by 5/9, which is really multiplying by 5 and dividing by 9, and that's 100. You could just as easily have put in 5/9, gotten the decimal, and multiplied that out as well. So very important temperature conversions. And you see it's hidden in here. It's linked to the measures of weight equivalents.